advanced types and features. So in this one we have 10 chapters, and first one we have seen in our access modifiers, right, packages, but we will cover here some more things, right? So as we did some practice in our access modifiers chapter, we will not do some code practice in this one. Okay, for this chapter, we will see some theory here. So access modifiers chapter introduced our packages briefly, and every Java class lives in a package. The package declaration is the first line of a source file, and the access modifiers use package boundaries to decide who can see what. Okay, and we will cover some deeper look in this one, how packages are organized on disk, all the forms of import, naming conventions, and java.lang auto import as well. Okay, also the role of package-info.java file. You can see here, okay, if you click on this plus, you can see here we have options package-info.java, module-info.java. So we will cover this one in next chapter and this one in this chapter. Okay. Packages as namespaces. A package is a namespace, a prefix that makes a class name globally unique. Two classes named user can coexist peacefully as long as their fully qualified names differ. And now, what is fully qualified names? We will see. So, this one is their fully qualified names, like with their package name as well. Okay, let's say their name is user and their package name is this one. So, they can exist together even in the same project. All right. The fully qualified name is the package name followed by the class name. When the compiler sees a simple name like user in your source file, it uses your import statements and the current package to configure out which fully qualified class you actually meant. All right. So let's say in this one you have form, then my company, then billing. Here you have this one, and analytics you have this one. Okay. So our compiler will generate something like that. Okay, you have to declare your package name here in both files. Basically, the folder structure on disk must match the package name directly or exactly. We have seen this one. Okay, means the files lives in compiler and runtime both enforce this. We have some conventions, all lowercase. Okay, not this one. Reverse domain name, right? No hyphens or underscores. Hyphens are not legal in Java identifiers. Group by functionality, not by type. Okay, that's fine. Now, next one is import forms, and this one is important. When we have to import any class, then our compiler needs to know where to find that. Okay, an import statement tells the compiler where to find a simple name that we use in our code. There are several forms which and each useful in different situations. First one is single type import, the most common form. Okay, let's say you want user invoice, then you can import directly something like that. Okay, with package name and then their class name as well. So you explicitly name the class you want to bring in. Professional Java code almost always uses single type imports. Okay, this one. And our IDEs can organize them automatically as well. They make dependencies explicit and keep our differences clean when you add or remove classes. On demand, wildcard import. So imports every public type in a package at once. We have this syntax, right? This is discouraged in most style guides because it hides which specific classes a file depends on. It is also the source of subtle conflicts. Okay, then another one we have fully qualified name, no import. So let's say if you have to use date, then you can use directly this one, java.util.date, okay, from this package, rather importing this one explicitly, okay. Without this, you would have to import one date and fully qualify the other, okay. Pick the one used most often for the import and qualify the other. Let's say if you have to write this one in just fewer places, then you can use this syntax. And if you have to use this in many places, then you can go with single type import. Now, fourth one, we have static import. Let's say you have some static fields or methods, in particular class, then you can import them directly, right? And you can use them without using their class name again and again. Let's say you want to use this POW again and again or SQRT, then you can use directly, but you have to be careful that you are not defining this method in somewhere in your file. Okay. So use static imports sparingly. They are most valuable for readability in mathematical code and in test assertions. Overuse makes it hard for a reader to tell where a symbol comes from. Okay. A static import can also be a wildcard. All right. Brings in every static member of math in this case, but it can have anything, right? And you can note that this one is only for static fields and members of this class. Okay. Now, next one is java.lang auto import. The package, this one is implicitly imported in every Java source file. This is why we can use string system these, without writing any import statement. No imports needed for any of these. They all live in java.lang. Only java.lang gets this treatment. Every other package, including util or IO, requires an explicit import. Now let's see some built-in Java packages, a quick map of the most used packages in standard library. Java.lang, core classes auto-imported. We have these, util, array list, and optional scanner, IO, buffer reader, input stream, file, and IO. We will cover this one, later. And these things, then java.net, java.time, java.util.concurrent, concurrency utilities, and this one is separate implementation on our collections, completely separate. And we will cover this one later, Now, next one is import rules and gotchas. A few less obvious rules that occasionally surprise developers. Imports are per file, not per package. Imports are not recursive, right? Same package classes need no import. Conflicts must be resolved manually. Importing two classes with the same simple name from different packages is a compile error. Use a fully qualified name for one of them, So let's say you do that. Import java.util.list, java.awt.list, compile error. Use list normally, import java.util.list, and you can use fully qualified name for other where needed. This one. So this one is very important case. If you have two classes with same names in two different packages, then and if you have to use them in one file, then you can define one or you can import one using direct syntax, and you can use other with fully qualified name syntax. Now the default package, a class that does not declare a package belongs to the default unnamed package. No package declaration. This class lives in the default package. Public class quick script. All right. But we have limitations for this one. The default package is intended for quick scripts and experiments. It has significant limitations. And what are those? Classes in the default package cannot be imported from classes in the named package. It does not work with the Java platform module system. We will cover this one in next chapter. Most build tools and IDEs treat it as a smell. Any real application should declare a proper package for every source file. Now next one is package-info.java file. This one is special file named and can live inside a package directory. It contains only package declaration and optionally package level annotations and Java doc comments. So this one is useful for our documentation. Okay. So let's create this file and you can comment these things. Okay, billing domain, and this package is single source of truth for billing state. You can do some annotations, package, okay, and these things. When Javadoc generates API documentation, the class comment from this one becomes the package overview page. Annotations placed here apply to every class in the package. Okay. Okay. So we can skip this one for now. This one is not much useful. Okay, in regular basis. But we can do definitely one code practice for our next file, which is module info. Okay. In next chapter, packages and access modifiers. We have seen this one and we have quick summary. Basically, we have covered our packages, okay, and their code practice in our access modifiers chapter. This one is just some more information about packages and imports, okay, some default packages, some built-in packages, all right, and how can we do importing in different forms, some naming conventions, packages as namespaces, all right. This is it for this chapter, and we can move forward with our next one, which is Java modules. This one is important. Okay.